Hi, Kumar again. Today I'm in dark glasses. When I wear dark glasses, you can't see really sometimes, right? Just imagine it's a blackout. All right? Now when you have a blackout, okay, a visual blackout, you cannot see. But very often, many of us look at diagrams with a blackout. An eye that cannot see the properties. This blackout. Ooh, hi, how are you? Now when you have this blackout, all right, a blackout, you fail to see certain properties. What you need to do is unveil the mask. The mask that blinds you from seeing the circle properties. So right now, all of you, let's unveil it. Yay! Great! Now, circle properties can be very easy if you know your 6 properties. And you just can flow, you can just see it fast. So that's a skill that you require. A very quick revision. What are the 6 properties? Remember, number 1, all right, angle in a semicircle. Great. Number 2, angles, same segment. All right, we call that what? Bow tie. Great. Third one, angle at center. What is about that? What about that? That angle at center is twice the angle at the circumference. The angle at the center, that angle there is twice this angle at the circumference. What about the next property? You know about cyclic chord? Yes, if it's 4-sided figure, a cyclic chord, the 2 different arms, all right? If you look at opposite angles, they add up to 180 degrees. Are there anything else we've lost out? RHS, right angle, hypotenuse side. Because of that property, we can see many things being equal, the 2 sides being equal. You'll be able to recall. So this picture should be in you, all right? Let's look at the first sum. In question 1, you're required to find out x and y from the given figure. Look at it carefully and see how you could. Now, if you look at this, all right, I also forgot one more property, but I told you, did I count right? Remember alternate segment. Yeah. All right, so count along with me, all right, see what I have left out. All right. Okay, when you look at this, what do you see? Alternate segment. Great! You saw alternate segment, this angle 52. And alternate segment is when a tangent mixed with a chord. So if this is 55, who is 55 now? It must be a triangle, and it must be looking at this chord. Now, it's a matter of who's looking and who. Who's looking at this chord? This angle, yeah. So this angle is 55 degrees. Now once you've got that, that is 55 degrees. Now you're asked, actually the y was supposed to be here, which was missing. I just like to fill in the y. All right. Now you've got this as 55 degrees. Now what is y? You've got here y. Where? Here, y. What is y equal to? Do you see another alternate angle? Alternate segment. Remember I told you alternate angle must never be said because alternate angles are only for parallel lines, remember. But this is a segment, an alternate segment. Look at this line here. Yeah, this is y. And y is facing not x. It must be a triangle. Look at this triangle, and y is 52 degrees because it's alternate segment. So what you need to do is when you write a equal to, just give an unknown, a equal to 55 degrees. What do you write here? Alternate segment. All right? But actually there's no necessity. Straight away you can find out y. Now y is equal to 52 degrees. What do you say again? Alternate segment. Now, with this information, we could easily find out what is this angle here. We call it maybe Z. Is that fine with you? Now, the purpose of finding out Z is that Z and X are related. What do you see? Don't wear your dark glasses. Throw it away. Something is blocking your vision. What is it? Yes, angles in a straight line. Alright, so we can find Z, 180 minus 55 minus 52 degrees. Now, if you look at that, you're going to minus 180 is going to minus 107 degrees. So what you've got is you've got 73 degrees, right? Good. And X and Z, all right, you have two different arms. Look at this set of arms, and Z, X is that. Two different arms. So we call them opposite angles of a cyclic chord. So what is X going to be? Yes, X is going to be 180 minus 73 degrees. We call it cyclic chord. Writing that is clearly visible what you're trying to specify. So your X is going to be 107 degrees. Excellent. So you found out what is Y and what is X. Alright? Okay. I hope you've got that picture. Very simple vision. Now let's look at a second sum. We want to find out what is X and what is Y. Look at this a cyclic chord. And do you see an alternate segment? The moment you see a tangent and you see a chord, you see this angle Y, which is equal to this angle here, facing that chord. You got it? Now, it's not 42 degrees because 42 will be here. If you look at this, if I call this Z, Z is 42 degrees. Alright? Because Z, 42 is facing this line and Z is 42. Alright, never mind. Let me write out. Z is 42 degrees. We call it alternate segment. And now we're going to find out what is Y. Now it's easily done. 180 minus these two angles. Alright, so your Y is going to be 180 minus 70 minus a 42. Now that will be a Y. 180 take away 70 is 110 minus a 42. 110 take away 40 is a 70. A 70 minus a 2 will be a 68 degrees. Got it? Great. So your Y is 68 degrees. Now once you've got 68 degrees, do you see this angle equal? Alright, that's 68 degrees. Right? Anyway, we want to find out what is Y. We don't need to be so inquisitive. But right now with me, we just want to learn also more. Right? You can see a Y here. This is also Y. Alright, and we could have found Y from the angle sum of triangle. Once we can identify this angle as Y, alternate segment, we can find this by angle sum of triangle, 180 minus these two. That's another method. Now, how about X? Alright, I think you've got it so fast. Okay? Well, X is going to be 180 minus a 70 degrees. You call that cyclic chord. And what is that angle? Well, it's 110 degrees. Excellent. Now, is that getting really easy? Very good. Okay? Now, it's something about circle properties and getting your perspective, the way you look at it right. Okay? Let's not be blinded by sometimes additional information or lack of information. Let's look at question 2. In a figure below, BT and AT are tangents to the circle. Alright, they're both tangents. There's an S there. Take note. Find angle BTA. BTA. Alright, they want to find this angle. Find AOB. They want to find this angle. AOB. And they want to find out ABT. ABT is the third angle here. Alright? Now what can you say from here about when you have two tangents, AT and BT? Yes, remember the tangent, the RHS property? If we have a circle and we have a tangent and another tangent, if we draw this a center, this is 90 degrees, and we draw a line across, these two radius are equal. This is a common side, and we have right angles here. So these two triangles here that you see, one triangle and this triangle, are both congruent. We call that RHS. As a result, these two angles are equal, and these two are equal. And the line from here, if I call it AX, will be equal to BX because of congruency. So similarly, we can say from the property that AT, alright, AT is equal to BT. What's the reason again? Right angle hypotenuse side. Alright, right angle hypotenuse side. If your teachers should understand, because if I were to draw a line across here, you look at this here, if I draw right here, you can see that AOAT and OBT are congruent. Alright, if we want to add on, you can. And as a congruent, and that's RHS. And as a result, AT is equal to BT. Now, because they are equal, triangle ABT is an isosceles triangle. We can say it's an isosceles triangle. And hence, angle, therefore, what can you say? Angle ABT is 42 degrees. We call that isosceles triangle the base angle of an isosceles triangle. Well, we've answered this part, no problem. Sometimes they can be all jumbled up, you can go. And you just put that as section, answer for C. Now we look at here. We want to answer AOB or BTA. How about BTA? Now, if you know this is 42 degrees, alright? You have 42 and 42. What is BTA equals to? Angle BTA will be none other than, alright, 180 minus both these angles. What's that you call? Angle sum of triangle. Alright, so it's 180 minus 42 again is minus 84 degrees. Reason, angle sum of triangle. A simple reason like that. And you get a 96 degrees. Yes. So angle BTA is 96 degrees. How about AOB? Alright? AOB. Look at this 42 degrees. Now I want you to look when you have a chord, and you have a tangent. This is 42 degrees. And what will this angle be? Isn't it facing the same chord? Well, this will be 42, right? Because it's alternate segment. So what you can say is, you could say that ACB is 42. ACB is 42. What's the reason? Alternate segment. As a result, if this is 42, this is going to be double of this. And this will be 84 degrees. You call it angle at the center equals to twice angle at circumference. Alright, let me find for you a space to write that out, because I think I'm really particular about how you write the steps. Now you want to find out what is AOB. So look at this first. You say angle ACB. Alright? Angle ACB is 42 degrees. What is the reason? Alternate segment. And once you've got ACB, angle AOB is twice of that. So therefore angle AOB is 84 degrees. Reason being, alright, write in the shortest form you can. Angle at center equal twice angle at circumference. That's all you do. Alright, now I can see the maths flowing with ease, and the next few questions I'm going to make it a little bit more challenging. Alright, so let's get our vision sharper. Alright, we'll get to the next few sums shortly.